This is lecture 27 on urban transportation planning. Route assignment will be the topic of discussion in this lecture, and we have completed in the previous lecture the topic of trip distribution analysis. You may recall, in trip distribution we discussed mainly about the gravity model of trip distribution, its calibration procedure as well as the application potential of gravity model. Then we discussed about 4 different types of models under growth factor method of trip distribution, starting from uniform factor method of distribution, average factor method, Fratter's method and Furness method. And there are certain limitations or drawbacks of growth factor methods of trip distribution. The most important ones are as follows. These growth factor methods simply reflect the base year condition. If trip interchanges between a particular zonal pair is very less in the base year condition, same scenario will be reflected for the horizon year situation also, even though there might be faster growth later. An extreme case of this possibility is that during a base year data collection you may find that trip interchanges between a particular zonal pair is 0, there are no trips, and after 20 years for the horizon year condition also, as per the growth factor method, you will be getting trip interchanges between those specified zonal pairs will be 0, which may not be realistic. Other related issues are related to the fact that the travel resistance is not taken into account at all in growth factor method of trip distribution, isn't it? Fij effect is not considered, which is very important. And third important aspect is related to data requirement. We need to have very elaborate data in the form of base year trip distribution matrix as input for growth factor method of trip distribution, which is going to be more expensive and time consuming. In spite of all these disadvantages, there are advantages which are specific to certain situation while making use of growth factor methods. One specific situation where growth factor method only can be applied in practice is in relation to analysis of trip distribution of zones external to a study area, or distribution of trips involving internal to external and external to internal trips. So we need to go in for only growth factor methods. Other possible situations are like short term forecasting of distribution of trips over say 5 years in an urban area where there may not be much of variation in the growth of travel demand. In such a case, nothing wrong in using growth factor methods and simply manipulate the available matrix to get the future scenario over a short term period. So that is how we need to understand trip distribution process. Please understand at this stage that we have gone through 3 important analytical steps in the 4-step planning process. Trip generation analysis, modal split analysis and trip distribution analysis are completed, right? And at the end of trip generation analysis, as I showed you earlier, this is what we actually had in respect of each of the traffic zones in an urban area. We just quantified the trip ends associated with each of the traffic zones when we completed trip generation analysis. These trips are person trips, not vehicular trips. percent trip ends associated or connected to each of the traffic zones were estimated on completion of trip generation analysis, which involves both trip reduction as well as trip attraction analysis, both together, isn't it. This is the result that we get at the end of step 1, and at the end of step 2, namely mode choice analysis, the same trip ends were further analyzed to associate modes for each of the trip ends. That is what we did in mode choice analysis phase. We determined the proportion of trips associated with different alternative modes available for travel. The color coding is given here. The modes available could be foot, motorized 2-wheeler, car, motorized 3-wheeler, intermediate public transport, bicycle, train, bus, and so on. This is what we did on completion of mode choice analysis, just assigning modes for the trip ends. Even at this stage they are only percent trip ends, but with an additional information of mode used for each trip, right. So that is what we have done on completing step 2, and we have now completed step 3, and on completion of step 3 we have some information about trip interchanges between zonal pairs. When you take two traffic zones, we know how to get information about interchange of trips between zonal pairs by a particular mode of transportation, and this could be for one mode, and similarly interchange of trips for another mode, and so on. Please understand, we analyzed zones taking two zones at a time. Zonal pair analysis was done in trip distribution, Tij, right. I and j will have unique values at a particular point of time, zonal pair trip interchange analysis, and we do this for all the traffic zones to get a complete trip interchange pattern for the whole urban area. Just to give you an idea about the complexity, let us consider 5 traffic zones. I have indicated zone centroids here, right, and at the end of trip distribution analysis, this is what we have done. The number of trips connecting the centroids of different zones, interzonal connectivity was analyzed. I have shown the methodology involving just 5 zone centroids. You can extend this to any number. So this is what we have done at the end of step 3, namely trip distribution analysis. Please remember, these are also percent trip movements, percent trip interchanges with associated mode. In fact, you will have this kind of picture for each of the modes, each of the alternative modes. One picture for distribution of trips using bicycle, another similar picture for distribution of trips using motorized 2-wheelers, and so on, right. So you will have number of such interconnectivities involving each of these modes. Clear? Now let us go back to our original master flow chart, flow diagram depicting the different steps involved in transportation planning process. I hope all of you recollect this flow chart. Where are we now? We are now here, route assignment by mode. After completing trip generation, modal split, and trip distribution, we are in this step, which is the 4th and final step in the analytical phase of the transportation planning process. It is very clearly indicated that the step is related to route assignment by mode. Okay. That means we are going to assign routes for the trip interchanges, okay, considering the mode of travel also. Okay. Let us see how we are going to do this exercise exactly, going through the steps involved. And incidentally, route assignment is one terminology used by authors. Another possible terminologies are trip assignment or sometimes traffic assignment, all are same: route assignment, trip assignment, traffic assignment, and so on. Now, the last phase of the 4-step transportation planning process is concerned with, as we discussed, trip makers' choice of path between pairs of zones by travel mode and with the resulting vehicular flows on the multimodal transportation network. Are you able to understand the statement clearly? In the previous phase, we estimated the total trip interchanges between zonal pairs mode wise, but we did not know the route followed. There could be several alternative routes between a zonal pair. Zone 1 and 2, you may have 2 or 3 alternative routes, and people might use all the 3 alternatives or sometimes only 2 alternatives, or worst case maybe only one route might be used. So, we must understand how people are choosing the route for travel from one zone to another zone. That is a question to be answered in this particular step, right. The question of interest is, given the estimate of interzonal demand by mode, that is what we have done in the previous step, to determine the trip makers' likely choice of paths between all zones along the network of each mode and predict the resulting flows on the individual links that make up the network of that mode. They talk about network for a particular mode. Normally you may perceive that a road network is common for all modes of transportation, but still there may be paths which are specified for a particular mode of transportation. You take for example bus transit system. Bus service is not going to make use of all the routes or links in the road network. Buses will follow a specified route. So, the number of links used by bus transit will be different from the number of or the pattern of movement by private transit or private transport modes, isn't it. So, that is how we need to understand the links related to a specified mode of transportation, right. Ultimately, when you try to assign trips made by all the modes, you will get the total link loading or the total loading on the whole of the network. Is that clear? And the estimates of link utilization. Obviously, once you complete the assignment process, you will find to what extent each link is utilized or loaded, isn't it. Can be used to assess the likely level of service and to anticipate potential capacity problems. After assigning, you will come to know the actual traffic volume on each stretch of a road. Some stretches may be relatively less loaded, that means level of service is better, you can move little faster. And certain stretches may be heavily loaded, resulting in poor level of service and indicating problem of congestion. All this information you can get after completing the assignment process. The number of available paths between any pairs of zones depends on the mode of travel, that is what I told you. Number of available paths depends specifically on the mode that you choose for your transportation. In the case of private transportation modes, a relatively large set of possible paths will be available, as I said, and also a good deal of freedom in selection between them, because it is your own vehicle, you can go this way, that way, and so on, a lot of freedom and relatively large number of alternative routes. On the other hand, typical mass transit modes, example bus, offer a limited number of path or route choices. It could be bus or even train. The routes are fixed, so you can take maybe to go from here to T Nagar either 5B or 47 series buses. You cannot take all the buses, any bus you want to go to that destination, because that mode gives you only few choices, right. And 3 preliminary questions must be dealt with prior to the performance of network assignment. Before you start your assignment process, you have to deal with 3 important questions, right. Then only you can assume that you are ready for getting into the assignment process. The first aspect is this, related to the difference between interzonal person trips and interzonal vehicle trips. So far in all the 3 trips, in all the 3 steps, we were dealing with person trips. Now we are going to deal with vehicular trips. You are not going to assign person trips on the roads or on the rail system, right. So it is concerned with vehicular movement. Traffic assignment or route assignment is concerned with movement of vehicles, not movement of persons. So this distinction has to be understood very clearly. This is the first point. The second is related to the difference between daily trips that is the estimate of the 24-hour demand versus the diurnal time of day distribution of this demand. Again, please note, when we talked about trips in trip generation, mode choice and trip distribution, those trips are related to daily trip, total of all the trips made for a 24-hour period on a typical working day. But when you assign trips in the form of vehicular flow, you know it is not going to be same throughout the day, right. So there is a need for understanding the hourly variation in the case of route assignment, whereas that was not necessary in the previous 3 steps. We were just dealing with the aggregate total number of trips made in 24 hours period. Third point to be remembered is concerned with the direction of travel of the trips to be assigned on the transportation network, because at the end of the traffic assignment step you are going to visualize the traffic flow over the entire network, transportation network. To visualize the flow, you need to know the direction of flow also. What percentage of movements are in one direction, what percentage is in other direction, right. So direction of movement is also very important in this particular step. So we should add little more information on each of these aspects. First related to a difference between person trips and vehicular trips, then related to variation of trips over time period, and third related to direction of movement. Clear? We will discuss in detail about each of these aspects. Person trips and vehicle trips. The forecast of the person trip and vehicle trip flows that are expected to use the transportation system are both relevant to the assessment of its performance. If we talk about system in general, we need to have information both about person trips as well as vehicle trips. It is acceptable, but still we need to come down to the specifics related to this particular process of route assignment. The estimated person trips that desire to use a highway, for example, provides an indication of the passenger throughput that will be accommodated. Even though on the highways or any road network we visualize only vehicular movement, if we have information with regard to number of people making use of that particular stretch of road, that gives you an additional information of the extent of passenger throughput through that particular roadway. So that is how, when you analyze the system, nothing wrong in having both information with regard to total person trips as well as vehicular trips. On the other hand, the level of service that the trip makers experience when travelling on the same highway is related to the vehicular flow that desires to use the highway, isn't it? How level of service related to vehicular flow? What do you understand by level of service of road? How do you define level of service of road? Level of service to some extent is qualitative in nature. It is the level of comfort enjoyed by the travellers when they are making use of a stretch of road. Comfort is related to various aspects, the freedom with which they are able to move, right, the extent to which they are able to maintain the desired speed, and the extent to which they are able to move in an uninterrupted condition, and the level of comfort they enjoy while moving on a particular stretch of road. All these things together is what we call here as a level of service, right. So level of service can be understood only when a traffic moves on a particular stretch of road. That is what is indicated here. So for this reason, the estimated interzonal person trips must be translated into vehicular trips prior to performing the highway trip assignment, or in general route assignment. Okay. Now the question is how to convert person trips into vehicular trips. Any response? How will you convert person trips into equivalent vehicular trips? First you should know the proportion of people making use of different types of vehicles, right. Then we know that because we have done mode choice analysis, we know proportion of travellers making use of different types of vehicles. Knowing that, how will you convert person trips into equivalent vehicular trips? It is a basic question to be clearly understood by any transportation engineer or planner. Unless you answer this question, you will not be able to proceed with route assignment, because we are going to deal with vehicular trips in route assignment, not person trips. Let us say there are 1000 person trips estimated to make use of motorized two wheelers from one zone to another zone, 1000 person trips. How will you convert the 1000 person trips into equivalent motorcycles. 1000 motorcycles. In certain cases 2 people may ride a motorcycle, in some cases 3, in certain cases whole family. We find all kinds of situations. So how do you convert the person trips into vehicular trips? Conduct survey, take measurement with regard to actual occupancy of that particular vehicle type. Go to the roadside, count the number of people making use of motorized two-wheeler, how many have only single rider, how many have 2 people, how many 3, and so on. Do it for a day, right, come back, get the average value. You may end up with 1.4 as the average occupancy of motorized two-wheelers, right, or 1.8, clear. Now you can clearly say when the total number of person trips making use of motorized two-wheelers is 1000, the number of motorized two-wheelers that will be really moving on the road will be 1000 by 1.8. It is as simple as that, but getting this 1.8 is not that easy. You have to conduct a detailed survey at appropriate locations to get this number, clear. Now mass transit, what is mass transit mode? Transit mode which can move more number of people at a time, must address another issue as well. In this case the specification of an alternative system consists not only of the fixed facilities that constitute the modal network, but also the scheduling of transit services. What do you understand by this? So we finally work out the number of vehicles based on mode choice analysis, and mode choice is done based on number of alternatives available for travel. Let us say we have train and bus services in mass transit modes available as 2 choices. From one zone, when you try to estimate the number of people making use of bus and train, you may end up with some proportion, maybe 70% making use of bus and 30% making use of train. This proportion pertains to your 24-hour observation. This is the average proportion, right. But here in route assignment you are going to consider the hourly variation of travel demand also, right. Let us say certain number of people want to make use of bus in the morning peak and certain number a train in the same period of time, right. So you should be very careful to check whether the frequency of service and capacity of the 2 alternative systems are sufficient to take this proportion. Are you able to appreciate this point? Morning peak hours may spread over say 1 or 2 hours or maximum 3 hours. Within that 3 hours, unless the frequency of service is sufficient by the mass transit modes to really provide for the modal share that we are predicting, then we have to rethink and do some adjustment in route assignment. Okay. This means that the analysis of a particular transit alternative must address the question of whether a proposed fleet size, number of vehicles, fleet size and operating schedule, right, and the related vehicular frequencies provide sufficient capacity to meet the anticipated interzonal person trip demand. Okay, there is another important issue associated with transit trips or mass transit trips. I think we have discussed sufficient enough to understand the complexities of converting percent trips into vehicular trips. Now second aspect is diurnal, time of day patterns of demand, variation of travel demand over period of time or temporal variation of travel demand. That is what we are going to discuss now. The road network flows that are used to calculate the prevailing level of service are expressed in vehicles per hour or PCU per hour, all of you know about it. The traffic flow in a road network is expressed normally in number of vehicles per hour or PCU, passenger car units per hour, right. I think all of you are clear about PCU, passenger car unit. Any question about PCU? All of you are familiar with the term, okay. On the other hand, the estimates of interzonal flows that are obtained by the trip generation distribution mode choice sequence are often based on 24-hour period. That is what we have been dealing with. When we say number of trips or trip ends, it is 24 hours travel, right, but we are going to deal with now hourly traffic flow, clear. But the demand for transportation exhibits a highly peaked pattern with sharp peak period in the morning and generally longer but less pronounced peak period in the evening. Is it true? Very sharp peak in the morning, a little flatter peak in the evening. Do you accept this statement? Why it is flatter in the evening and sharper in the morning?
Time for attending the work or work to the office is normally fixed time, and while returning back from the office to the residence, it may vary from office to office or from person to person. That is why it is distributed.
Good, exactly. See, normally in the morning when you start the work, you have to go for work in time, report for work in time. Everybody would like to go in time, and at the end of the day, no boss questions his colleagues or her colleagues when they stay back late in the evening and work. They will be happy if they are working, staying back in the office and working for a long period, and depending upon the working capability and workload and things like that, the dispersal time will be spread over a longer period, normally in the end of the day. That is how normally typical cases it is very sharp in the morning, a little flatter in the evening. And of course, if there is a different attitude of workers, if they want to work to rule, right, leave the office at the stroke of 5 o'clock or 5:30, then you will get sharper peak in the evenings also, right. It might happen in certain cases, it all depends upon the attitude. It is appropriate therefore to investigate the performance of the transportation system under peak demand conditions when capacity limitations become most critical. This is the most important point to be remembered. There is no point in taking daily average and doing your route assignment. So you just check for the capacity of the system when the demand is high during peak period. The time variation of demand is most relevant to mass transit planning because the scheduling of service is typically tailored to the variation of demand over the 24-hour period. This is the most important point. In the morning hours, everybody will be moving from home to the activity centers, which are most likely to be located around one central part of the urban area. So the whole of the traffic converging towards one point, and transit system operators should be able to operate their fleet to meet this demand. Think of bus operators. Let us say they are operating bus service from different production zones to the activity centers near CBD, drop the people there in the morning. When the bus is returning, it is going to be almost empty, right. How do they ensure economic viability of operation? These are all the questions. to be answered, right. That is why it is very critical for mass transit service operation. The diurnal distribution of demand may be estimated through the use of factors taken from observations during the base year, or it may be explicitly modeled in the preceding steps of the demand forecasting process. It is nothing but determining or quantifying the peak demand. How to quantify the peak demand? One way is you observe the demand and its variation in the base year, right, but you will be assigning traffic for base year condition and later for horizon year condition also, is not it. After base year process is over, you are going to use these 4 models to do the same exercise for the horizon year condition, right, and your interest is to know the horizon year peak situations also. The simple question is, what percentage of the 24-hour traffic will constitute morning peak, is not it. It is a reasonable question. Unless you understand the answer to this particular question, you will not be able to really quantify the peak demand and assign the traffic. So this can be done based on our base year information, or there are empirical models available using which you will be able to quantify the horizon year peak demand both for the morning as well as evening. Typically the morning peak period demand is in the range of 10 to 20% of the total daily demand. The range itself is very wide, 10 to 20% of the total demand is occurring in the morning peak, which might be spread over normally 2 to 2.5 hours, maximum 3 hours. Clear? It is only an information, you need not have to worry about these numbers. We have to take the value from the field observed data, and you can also think of similar situations which have already experienced the horizon year condition for your city. Standard practice entails the performance of 3 separate assignments by the time of day: the morning AM peak, right, the evening PM peak, and the off peak balance of the day. You have to do assignment for 3 traffic demand situations. You just quantify the demand for AM peak, do the traffic assignment, then PM peak, assign the traffic and visualize the traffic scenario, then non peak period you just quantify the demand and then assign and visualize the traffic flow, right, which is similar to the desired setting for traffic signals. As traffic engineers, you might know that you cannot have a single signal cycle for the whole of the day to manage traffic at intersections, even though in our country in many cases they just fix only one cycle time and manage to regulate the traffic. You should have different cycle times and different phase split, one for morning peak, one for evening peak, and one for non peak hours. If necessary, you can go in for more cycles also, and traffic signal should be really dynamic, because truly dynamic traffic signals are vehicle actuated traffic signals. You can install sensors on all the approaches. Depending upon the number of vehicles waiting to take a particular route, the signal will change its phase, red to green and so on. That is very important. And for planning purpose, desirably we can do 3 different assignments, one for morning peak, one for evening peak, and other one for non peak hours, because it is for the purpose of planning at the macro level. This is good enough. Then about the third aspect that we listed initially, the direction of movement, trip direction. In the discussion of trip generation, a distinction was drawn between productions and attractions. We differentiated between productions and attractions, and we did not bother about the direction of movement while doing trip generation analysis, isn't it? We never assigned direction of movement in trip generation analysis, right. It was also explained why most trip generation models estimate productions rather than origins. It is convenient because we designate zones as production zones, attraction zones and so on. There is no need to worry about trip origins, trip destination at that stage. Okay. The point made here is the direction of movement was not considered while you quantify the total trip ends associated with traffic zones, that is the point. However, it is desirable that assignment of trips, especially by the time of day, retains the direction of these trips. It is obvious, that is what we discussed about. While you assign traffic, the direction of movement has to be retained, which is possible by converting your PA matrix into OD matrix. That is why we discussed about conversion of PA matrix into OD matrix only for this particular purpose. The predominant direction of travel during the morning peak, as we discussed, could be towards major activity centers like CBDs, educational institutions, etc. And the reverse is true during evening peak, obviously. And the experience and knowledge accumulated through studies of travel patterns within the region aid in the accomplishment of this task. So, a lot of experience about the travel pattern of the urban area that you study helps you to analyze the peak and non-peak demands much better. And of course, the CBD movement towards CBD etc. applies to cities of certain size. When the cities become mega cities like Chennai, Mumbai, Delhi, Kolkata and so on, these cities develop a number of nuclei. They become multi-nuclei cities. You have several CBDs. If you take Chennai city, the Paris corner is one CBD, Anna Nagar another CBD, T Nagar third CBD, Mylapore one other CBD, Adayar area another CBD. Now Velachery is developing as one more CBD, Thambaram different CBD, clear. So there are several nuclei being developed in mega cities. So you cannot apply the concept of everybody converging towards one active location in urban area when the city size is beyond certain limit. Okay. That is why this statement is very important. The experience and knowledge accumulated through studies of the travel patterns within the region aid the accomplishment of this task. Directionality factors by time of day and trip purpose are typically used to convert production attraction tables to origin destination tables, about which we have discussed in detail. What do you understand by this proportionality factor? The value of alpha that we used for converting PA matrix into OD matrix, the percentage proportion of trips that are originating from a particular traffic zone, that is what is indicated here as proportionality in this particular context. So having discussed in detail about the three aspects, what are the three aspects? First one was related to conversion of person trips into vehicular trips. Second one was related to temporal variation of travel demand, and third one was related to direction of movement. Okay. So, all these three aspects are to be given required attention while you start assigning traffic on various routes. And to assign traffic, first we need to represent the network properly pertaining to your urban area. How are we going to represent the road network? Because this is an analytical process. The entire road network will be going as input for your route assignment analysis into a computer program. You cannot give the city map as city road map as input to your computer program. So, the network of road should be understandable for analytical purpose, right. So, you must by some way represent the road network analytically in such a way that this information goes as input for your route assignment analysis. Clear? Let us see how to go about doing this. As the first step, the highway network is described by a system of links and nodes, right, system of simply links and nodes. A link is a section of highway or simply road network between two intersections. In a road network you may have intersections, right, crossing roads, right. The stretch of road between consecutive intersections is termed as link. Okay. You have Madhya Kailash intersection, then there is a Kotturapuram road junction in front of IIT, isn't it? The stretch of road between Madhya Kailash and IIT is one link. Stretch of Sardar Patel road over this particular portion is one link, right. A node is either the centroid of a zone, namely traffic zone. You know what is traffic zone now, centroid of zone, or intersection of two or more links. Okay. Road intersections are nothing but intersection of links, isn't it? So, each road intersection is considered as a nodal point, node, and your zone centroids are also considered as nodal points, right. Zone centroids are not fixed at road intersections, they are fixed based on set of different criteria about which we will discuss later. Okay. As of now, understand that all road intersections are considered to be nodal points. All the zone centroids are also considered to be nodal points. Usually local and minor streets are not included in the coded highway network, that is very important. Do not include every minor street, lanes and by lanes in your network, they are not relevant at all. You must think of the roads which constitute the main network reflecting or taking the major flow of traffic in the urban area, right. The choice of roads to formulate a network is very important, right. Let us consider a small example to understand the concept much better. This is a small portion of an urban area, heavily built up urban area, and we are trying to convert the roads involved in this area in the form of coded network, right. Let us say this is the traffic analysis zone boundary, the dotted line indicates the zone boundary, isn't it? That is how you can fix the boundary obviously, right. you cannot just make the boundary line to cross the yellow colored portion. Boundaries can be only obviously along the roads, is not it? And later on we will see how to really make these dotted lines, how to fix the boundaries for zones. We will discuss later in transportation survey about fixing boundaries for zones. As of now, understand that this is the way the boundary line is fixed for traffic zones. Now our interest is what are the roads or links and nodes relevant to this particular traffic zone, that is our question. Please note there are several roads that are relevant to this zone. If you take in the horizontal direction, one road on top, there is one more road here and one more road here. There are 3 parallel roads, okay, in east west direction that are relevant to this particular traffic zone. In addition, you have one minor road in east west direction, one more minor road, this alone is the additional road in the east west direction. In the north south direction we have one major road here, another major road here, third road here, and there is one more minor road in the north south direction in this area. Clear? Now the question is, should we have to consider all the roads for making the network, or we can afford to ignore some of the roads? That is the question. And one suggested network for this zone is this. We have given node numbers for the road intersections, right. How many roads we counted earlier? More than the number that is shown here. You may recall we observed 3 roads in east west direction, major roads, and one more minor road, totally 4, and we have considered only 2 roads in east west direction, and there were number of roads in the north south direction. We have considered only 3 roads. Other roads are not considered because they are minor roads, and major and minor distinction should be based on the actual traffic flow on the roads. Clear? So this is the network, nodes and links pertaining to this traffic zone. Clear? I will go back to the picture, please look at it, and we have ignored this minor road. We have also ignored this road, this is also not taken into account, right. This is also ignored, this road is also not taken into account, right, because these roads are minor roads. And later on we will see how to account for the vehicles making use of these roads as the traffic generated from this particular traffic zone. Clear? So this is how we convert the road network into nodes and links. And what is the designation of this link? How to name this link? Name this link simply as link 315 316. Links are named using node numbers. Okay, use the node numbers to name the links. Clear? That is how we manage. Now there are some numbers which can be used to designate a road intersection, to designate a stretch of road. Can you not perceive at this stage that these numbers can be used as input to give information about your nodes and links in a city road network? It is possible. So you can convert your entire road network into some set of numbers and give that as input for your analysis. When you say 315, give 315 as input, that represents a particular node in a particular location university. You are not going to give 315 for any other intersection, clear. And when you say link 315 316, that is going to indicate only at that particular stretch of road, no other road, isn't it. So that is how conversion of the road network into links and nodes helps you to analyze the whole network easily, or give the information as input for the analysis, clear. So we will stop here and continue the rest of it in the next class. And to summarize what we have seen today, we started our discussion with a clear understanding that in the previous 3 major analytical steps, namely trip generation, mode choice and trip distribution, we handled only percent trips, whereas in route assignment analysis we will be handling vehicle trips. In that context only we discussed about 3 important points related to route assignment. The first one was converting person trips into vehicular trips. Second important aspect was converting the daily traffic demand into hourly traffic demand, realizing the temporal variation in the demand for transportation. And third aspect was related to direction of movement, because we are going to deal with traffic flow. And finally we have understood the method of representing the road network in the form of links and nodes, right. We will continue the rest of it in the next class.